Hi everybody. So today we're going to talk about section 2.4. Okay. Alright, now, in this we're going to talk about interval notation and linear inequalities. So the first thing we have to understand is the ways we can represent an entire set of numbers. Okay. So for example, let's say we have this information that we know that x, our unknown, has to be greater than 6. Now, I've just written that as an inequality. Okay, x is greater than 6. But what does that mean? Well, let's look at a number line. Okay. Now, in a number line, normally we put 0, and the positive numbers go this way. Somewhere we get up here to 6. Okay. And if we keep going, let's see, so 1, 2, 3, 4, 5, 6, okay. Then down here would be negative infinity. The negative numbers would go this way. Okay. So if I want to represent all the numbers that are greater than 6, okay, I like to use open circles. Okay. And the numbers that are greater than 6 go this way. Okay. Now I use an open circle here because this is just greater than 6. It's not greater than or equal to. Okay, so if it was equal to, I could put in, I would fill in that circle. Okay. Now in interval notation, notice this represents all the numbers that go between 6 and infinity. Okay. So in interval notation, the way interval notation will work is you always start with the lowest value, and then you put a comma up into the highest value. Okay. And then these will either get capped with parentheses or brackets. It could be a bracket and then a parentheses. Let me show you. Okay. So in this case, the lowest value we have is 6. Okay. And the highest value we have is infinity. Now remember, infinity is not a number, it's just a concept. Okay. Since infinity is a concept and not an actual number that you can grab a hold of, it will always get a parentheses. Okay. If it were, now for 6, if 6 was included, I'd put a bracket, but 6 is not included, so I'll also put another parentheses. So let's practice using this. Okay. Now this is true. This number line graph can be very, very useful, even if it's not required. I use them all the time. Okay. So first of all, let's draw in a number line. Okay. Now the important part here, our reference is -1, so I don't have to draw out the zeros and everything. Okay. We're just going to reference this. Now the inequality, this says x, our unknown value, is less than or equal to 1. Okay. Now since it can be equal to, I will fill in the circle showing that it can be included. And then the numbers that are less than this, well, that comes all the way down to infinity. Any number in here, this is the number line representation of x being less than -1 or equal to. Okay. Now in the interval notation, remember that we want to go from lowest to the highest. Okay. So the most left number here is actually is negative infinity. Now that's not an actual number, so it'll never get a bracket. Okay. Then I have to put in the comma, and the highest value that I come up to is -1, and it is filled in so it gets a bracket. Now, I like to use open and closed circles because I think they're easier to read. You can use parentheses here, and parentheses represent those open circles, but I prefer the open circle. I think it's much clearer. Okay. So let's say, now this is -2 to +1. Okay. Once you have the number line, it's very easy to write the interval notation. Okay. the lowest value that we have is negative 2, but it's not included, so it gets a parentheses. Then comma, the highest value we have is 1. It has open circles, so it is not included, so you'll get the parentheses. It will get the parentheses. Okay. Now the difference is, how do we write this inequality? Now the inequality needs to have an x. Okay, there is some variable. Notice here x really only had a bound of negative 1. Negative infinity is not a number. Okay? Now here, x does have a bound. It can go in between these two values. So the lower bound is negative 2, and the upper bound is 1. Okay? So that is, negative 2 must be less than x, right? Or x must be greater than negative 2. And then x must be less than negative 1 at the same time. That is, it's going in between these two values. Excuse me. Okay. Now here we're given the interval notation. Okay. The specific number we're given is 2, so we put that on the number line. Okay. Now there is a parenthesis around 2 indicating that 2 is not included, so that will be an open hole. So the lowest value the x can take on is 2, and the highest value is infinity. Well, infinity is in this direction, so then I can shade the number line this direction. Okay. So when we write the inequality, we need our variable x, and we need the reference point 2, and then we have to decide which sign goes in here. Well, the numbers I have shaded are greater than 2. Now here's an interval from 5 to 7, and these have brackets. So now on the number line, I have 2 points of reference, both 5 and 7. The brackets here indicate that 5 is included. So as opposed to an open circle, I put a closed circle. And this bracket also indicates that 7 is included. Now the interval tells me that the lowest value x can take on is 5, and the highest value x can take on is 7. So anything in between here will satisfy the interval. So again, we need a variable for inequality, but there are 2 bounds on it. There's the 5 and the 7. And x can go in between these, so 5 must be less than or equal to, because of the filled in circle, because of the bracket, and x must be less than 7 because of the bracket, because of the filled in circle and the bracket. Now this is an important inequality. The point of reference is 0, and we're saying if x is greater than 0, not greater than or equal to, so it's an open circle. And so this is how we would shade it. This is another way of saying that x must be positive. And if we write that in interval notation, the lowest value x can take on is 0, but it's not included, comma the highest value. Well, the highest value is infinity. Infinity will never get a bracket. Then on here, another way that you can represent inclusion on a number line is with a bracket. I prefer the closed circle. I think it's clearer to see. So now, for the inequality, we need x, and we need to know its point of reference is -5. But what are these values? Well, these are the values that are less than or equal to -5. So if we were to write this in interval notation, the lowest value on this number line is -infinity, and the highest value is -5. But 5 can be included, so we'll put a bracket. Now, before we move on, I just want to make some clarifications on the homework problems. Okay. So in number 4, 2 has an open circle, and pi has a closed circle. So this is 2 and this is pi, and it's going in between here. Okay. In number 5, 4 has an open circle, and it is shaded downwards. In number 9, that's a bracket, so it should actually be a closed circle and go to infinity. And then on this one, they're both open circles from -7 to 3. Okay. So I just wanted to clarify that. You can write it either way with parentheses or brackets, but I think the open and closed circle are clearer. Okay. All right. So that'll get you through your first 14. Right? And now we can talk about solving linear inequalities. Okay. Now, when we solved equalities, like for example, if we were solving x minus 2 is equal to 4, this is an equality, okay? We have an equal sign. Then we'd simply add 2 to both sides to get x equals 6. And this was one solution. If you're solving linear inequalities, now these are just linear because there's no exponent on x, we're going to get an entire set of answers, okay? So we can do the same thing that we did up here. I was able to add right across the equal sign, and I can do that. I can add or subtract the same number on both sides of an inequality. Okay? So if we add 2, it now reads, okay, this goes to 0, x is less than 6. Okay? This is an infinite amount of solutions. So x equals 1, x equals -5, etc., etc. There's an infinite amount. If you were to graph it, here's 6. This would be all of the solutions. Okay? There would be an infinite amount. And in interval notation, it would go from -infinity to 6, not included. Now we can also multiply and divide by the same, now this is important, positive number. Okay? So if I needed to get to 3 x's, I could divide by 3. So I'd have that x is greater than -5. If we put that on the number line, here's -5. -5 cannot be included, there's no equality there, and x needs to be greater than that. In interval notation, the lowest value is -5 and goes to infinity. Infinity never gets a bracket, and 5 won't in this case because it's not included. Okay. Now, here is the biggest thing, the change, okay? If you're going to multiply or divide the inequality by a negative number, we have to flip the inequality. Okay. Here's why. Okay. Let's say I want to multiply by a -1. Okay. Now on this side, this is right now it's a true equality. -6 is down here, and +4 is here. So -6 is less than 4. Okay. But if I multiply by a -1, this side now reads +6 And this side now reads negative 4. Okay. If I leave the equality the same, this is not true. Because if you look at it on a number line, number 4 is down here, and negative 4 is down here, and positive 6 is up here. The truth is that 6 is greater than negative 4. Okay. So this is what we're talking about. You'll need to flip the inequality. And just one more example like this. Let's say I wanted to divide by a negative 1. Okay. Then this side would become, right now this is true, okay. 1 is greater than negative 2. Okay. But if I leave it like this, we'll get negative 1, positive 2, and if I don't flip the equality, I have something that's not true. If you try to graph this, here's negative 1 and here's 2. The truth is that negative 1 is less than 2. Okay. This is true. Okay. So I needed to flip this sign. Okay. So now let's see if we can solve these. Alright. So let's first add 3 to both sides. I can do that. 4n is greater than negative 11 plus 3 is negative 8. Okay. And what I want to divide by is 4. Okay. So the 4's will cancel. And n has to be greater than negative 2. So this is our inequality. If we were to put this on the number line, negative 2 is our point of reference, and n is our variable. It can be greater than but not equal to, so an open circle, and greater than goes this direction. Okay. And that takes off to positive infinity. So in interval notation, the lowest value is negative 2, then comma our highest value, which is infinity. Infinity never gets a bracket, and negative 2 is not included, so it will not either. Now in number 2, we want to divide by a negative 2 to get to y. Okay. The negative 2's will cancel and we'll be left with y, and the negative and negative become positive, and 2 goes into 10 5 times. However, we must flip because we divided by a negative. We must flip the inequality. Okay. So this is our solution set in inequality. If we were to graph it, 5's our point of reference. It can be included because of this or equal to. Okay. And y has to be greater than that. And that'll take off to infinity. So in interval notation, the lowest value that y takes on is 5, comma, the highest value is infinity. Infinity never gets a bracket, but 5 will in this case because of the equality. Let's try some more. Okay. Here's another example. Okay, good. Alright, so remember this negative x is like a negative 1x is less than 2. So to get rid of that, we can multiply by a negative 1. Okay. We have to do it on both sides. Okay. So what we'll have on this side is positive x, and what we have on this side is negative 2. Positive and a negative become negative. But then we're going to have to remember that since I multiplied, by a negative, x has to be greater than -2. We have to flip that sign. So if we put this on the number line, -2 is our point of reference. It is not included because there is no equality, and x can be greater than that, taking off to positive infinity. So in interval notation, the lowest value is 2, the highest value is infinity. Infinity never gets a bracket, and -2 doesn't in this case because there's no equality. Okay, let's do number 4. Right? So if we can, we always want to simplify. So let's distribute this -6 through. So we get x minus 6x plus 12, and then less than or equal to 5 plus 2x. Nothing to simplify on this side. Now let's combine these like terms to get -5x plus 12 is less than or equal to 5 plus 2x. Okay, now let's get the x's on one side. Maybe I'll subtract 2 x's. Okay. When I do that, this does not become 0. This becomes -7x plus 12 less than or equal to 5, and this goes to 0. Now if we subtract 12 from both sides, we have -7x. This goes to 0, less than or equal to 5 minus 12 is -7. And now we can divide through by -7. So we'll get simply x is equal to positive, not equal to +1. Over here we'll have +1. But we have to remember, I'm divided by a negative, so I must flip the sign. Okay. So in interval notes, well, let's do the number line first. So in the number line, 1 is our reference, and it's x can be included, including 1, and it needs to be greater, taking off to infinity. So the number line, that's the number line, and the interval notation, the lowest value x can take on is 1, and it is included and goes to infinity. Now in this example, we have the negative to deal with and the fraction. So let's multiply both sides by -1 first of all to get rid of that negative. Okay. So this will become positive x over 2 and -5. But we're going to have to flip that inequality. Now let's multiply both sides by 2 because it's like 2 over 1, so these will cancel. So we have x is less than or equal to now -10. Putting that on a number line, -10 is our point of reference. Okay. X can be equal to, because of this little line, the -10. Okay. And then it can be less than that. And that's taking off towards negative infinity. So the interval notation for this, the lowest value is negative infinity and goes all the way up to -10, and will include -10. Now here, let's use the same methodology. Let's multiply by a -1. Oh wait, no, we don't have to. X is already solved for, isn't that? Okay. So this already says negative 8 is greater than or equal to 1x. Okay. Now, what I'm about to do is different than what I've done here. Okay. Here I multiplied by a negative 1, so I flipped the inequality symbol. Okay. Now the thing is, x is already positive here. Okay. But I prefer, when I'm reading inequalities, that I have the variable on the left-hand side. And you can read inequalities in two different ways. Okay? This says negative 8 is greater than or equal to 1x. It is also true if I take the 1x and the negative 8. Okay? Now I'm just going to rewrite this. I haven't multiplied by anything. Okay? To keep the equality true, I need to be open towards the negative 8. Okay? And the arrow pointing to the negative 1. So these two are the same statement. If negative 8 is greater than or equal to 1x, then it is also true that 1x must be less than or equal to negative 8. Let's try another example. Let's say I have 6 is greater than x. Okay. I don't like having the x on the right-hand side. I prefer the x on the left-hand side. Okay. So I can rewrite this. Now I'm not multiplying by anything. I'm just going to maintain the inequality. So right now, the 6 is the inequality is opening towards the 6. So if I do it like this, this is true. If 6 is greater than x, then x is less than 6. Okay. Now, let's do number 7. Okay. So we have fractions, and let's just do what we always do with fractions. Let's get a common denominator. In this case, 6 is going to be the fraction. Remember, this is over 1, so I can multiply this by 6 and by 6, this one by 2, by 2, by 3, and by 3. So this becomes 9 over 6 minus 2x over 6 is greater than x over 6. Notice I didn't have to do anything to that one. It's already over 6. Minus 6 over 6. And we can just write this as one great big fraction. So this is 9 minus 2x. It's greater than 6 over 6. And x minus 6 up top. Now that I have the common denominator, I can just multiply by 6 on both sides. The 6's will cancel. And we'll be left with just the numerator. 9 minus 2x greater than x minus 6. And in this case, let's add 2x. So this becomes 9 minus 0 is greater than 3x's minus 6. So if I add 6 to both sides, we have 15 is greater than 3x. Or now dividing by 3, we have x is greater than 5. I'm sorry. 5 is greater than x. But here's an example of the variable being on the right-hand side, and I don't like that. I would like it on the left-hand side. So now the variable, the inequality sign is opening towards the number 5 and pointing towards the variable. So this is an equivalent statement. If 5 is greater than x, then x is less than 5. And we could put it on the number line. Here's 5, and this is why I specifically prefer the variable on the left-hand side, then it's easier for me to graph. Okay. 5 is not included, and x needs to be less than that, taking off to negative infinity. So that the interval notation goes from negative infinity to 5, not included. Okay. Now there's also such things as compound inequalities. This is really two separate inequalities. This is saying a is less than x by just looking at this one. And also what must be true is that x must be less than b. Okay, so if you have a compound, you could split it up into two separate ones and solve. But we don't have to. The great thing is when they're set like this, we can just solve them all at once and work all three sides at the same time. So one thing I want to do is I want to get to x. We want the x's to be in the middle. So let's get rid of everything. All right, I could add 6 to all sides. Now negative 4 plus 6 is positive 2, keeping the sign less than or equal to. This goes to 0, so we're just left with 2x in the middle, less than or equal to 8 and 6 or 14. And then we can divide everything by 2 to get to x. So 2 divided by 2 is 1, less than or equal to x, less than or equal to 7. So on the number line, we have two bounds, 1 and 7. Okay. They are both equal, so they can get a filled-in circle. And any number in between there will satisfy it. In an interval notation, the lowest value is 1, it's included. The highest value is 7, it's also included. Okay. In this example, everything's being divided by 2, so let's multiply by 2 to get rid of that fraction. So negative 2 and positive 2 become negative 4, less than or equal to, these 2's cancel, and we have x plus 1, less than or equal to 10. And now we can subtract 1. So we have negative 5 is less than x, which is less than 9. On a number line, our two important numbers are negative 5 and 9. They will get open circles because there's no little line underneath here. Open circles, and any number in between them will satisfy it. So in interval notation, the lowest value is negative 5, comma, the highest value is negative 9. Neither of these are included, so they'll get parentheses. In this example, let's subtract 1 from all sides. So negative 7 is less than or equal to negative x, less than or equal to 1. And we don't want a negative x, we want a positive x, so let's multiply by a negative 1 on all three sides. So a negative and a negative become positive. Negative and negative become positive, and positive negative become negative. Okay. But now we've multiplied by a negative, so we need to flip the signs. Okay. Now on a number line, let's flip this so I like these numbers to represent the way they would on a number line. Remember, on a number line, negative 1 is here and 7's up here. So let's make this inequality work that way. Okay. So I'm just rewriting this. So we have negative 1, x, and 7. And now I need to make the signs agree. Okay, so this sign opens towards the 7, so I need to keep it that way. And this sign opens towards the x, so I need to keep it that way. Okay. So these two are equivalent. Okay. Now I can fill in the number line much easier. Negative 1 is included. The highest value is positive 7. It's included. And any value in between there will work. So in interval notation, it goes from negative 1 to 7, included. So there's a difference about flipping the signs because you're multiplying and rewriting the entire inequality. Okay, let's do the next example. Okay, let's try and simplify as we would. The left-hand side is already simplified. It's simply x plus 2, and we'll leave the greater than or equal to sign. The 4x, and then let's distribute this negative 3 through. So negative 3x minus 3. And now x plus 2 is greater than or equal to. Let's combine these like terms. So we'll get x and then the minus 3. Alright, now let's try and get x's on one side, so I'll subtract x from both sides. And what happens then is x minus x goes to 0, so we're left with 2 is greater than or equal to, and again on this side it becomes 0, negative 3. And this is a true statement. Okay? Here's negative 3 and here's 2. And 2 is greater than or equal to negative 3. So it turns out we're in one of these unconditional situations that it is, it's true for all real numbers. True for all x. And when it's true for that, if it's all real numbers, we can put, now this is the interval notation for all numbers. Okay. Remember the number line goes from negative infinity to infinity. So it's true for all values of x. Again, let's simplify over here. There's nothing to simplify on the left-hand side, but we do need to distribute that negative. Okay. So I'm going to have to change the sign. So this is minus 4x plus 2. Again, just copying the left-hand side. And if I combine these like terms, I get negative 3x plus 2. Now, let's try and get the x's on one side. So I'll add 3x to both sides. When I do this, I'll get 5, and this goes to 0, is less than, this goes to 0, is less than 2. So here's 2 and here's 5. This is a false statement. Okay. 5 is greater than 2, not less than 2. So this is a contradiction. And as for a solution, there is no solution. Okay. So contradictions and unconditional situations can occur in both equations and in inequalities. Okay. Alright, so that should get you through your homework. Yeah, that's your homework. Be careful down here about reading whether things are equal to or not. Notice 35 and 36 are the exact same problem, except one has a less than or equal to, and one has a less than. Okay. So there will be different solutions to this problem. Let me know if you have any questions.